What? Okay. Hi everyone, Mr. Zhang here. Folks, I'm going to do a little review for you, and this is a review on atomic theory. So if you look on my left side, you'll see that. So I have slides on the left, and I have the note sheet, and you can follow along. Now, you're not required to actually do this note sheet because we're assuming that you know some of this stuff already. But in case you want to, just do a review with me, then here we go. So what's our focus question today? The question is what does so I'm gonna write this in here. What does atomic theory tell us about atoms? Okay, so that's the focus question here. So let's talk about this word atom. Where does it come from? So if you look on my left here, you'll see that this word atom comes from the word atomos. Right, so it's the word atomos. Okay, and it's a Greek word. It means smallest indivisible particle of matter. So what's the definition of an atom? Of the word atom? Well, it is the smallest piece of matter. Okay, so that is the definition. Now you might know about the Bohr model. You're very familiar with it. It looks like this. It comes from scientist, right, physicist Niels Bohr, and is actually he has a lot of contribution. But you know of these three particles already: the proton, right, proton, the electron. Let's do a negative sign. Electron, and of course, there's one more: the neutron. Right, it's just neutral, so it's just nothing. Call this the neutron. Okay. And of course they have their different charges: -1 plus, right, -1 plus 1 and 0. And usually this is what it looks like. Now if you look here, you'll see that I have the Bohr model shown here. Now there are electrons. So there's several things that you need to remember. The first thing is the nucleus, right? This is where the proton and the neutron live, right? So we call this the nucleus. And electrons live on the outside. This area is called the electron cloud, or sometimes also called energy level, right? Electron energy level. So that's what we call them. And the electrons on the outside are called valence electrons. Right? So there are these electrons on the outside here. Okay. Here, and here. Now, why am I talking about valence electrons? Well, when chemicals form bonds, right? Sorry, I'm skipping a little bit. They use valence electrons. And you might know the definition of elements already, but essentially, if you put a bunch of, so I'm gonna go like this. Essentially, if you put a bunch of these same atoms together, it is then called an element. So, I'm talking about this right here. And of course, scientists have put them on a periodic table. Now, elements are arranged in the periodic table by their number of protons, okay, as well as their characteristics. Here you go. You guys seen periodic table before. So there's another vocabulary you need to know. What's a compound? A compound is when you have more than one atom bonded together, and they have to be different elements. Okay, so that's what a compound is. Okay. All right, moving on. So on the periodic table, you'll see that there's these squares in there, right? You'll see these. Well, how do you read a square? So let's go here, okay? Well, when you're looking at this square, there are several things that you need to take a note of. The number here, this is called the atomic number. And it tells us the number of protons and the number of electrons. This is the chemical symbol. Chemical symbol. And here is, of course, the chemical name. And lastly, this is the average atomic mass. Okay, so it tells us a lot of information at the same time. But what about the number of neutrons? We don't know where's that? Where's that information, right? What about number of neutrons? Well, there's a way to calculate it from the information that we're given. Usually what you do is we're looking at this, right? So the way that you calculate it is n equals the mass, so you have to round it, minus the atomic number. Okay, so let's do our example here. So here we would have n equals, our example is 12, right? So n equals 12 minus, right? So we round it to 12 minus, in this case, 6. So the number of neutron is 6. Okay, so that's how we do it. Now, if you want to practice, you can try these two. Okay, they are argon, right? So you can try argon and krypton, right? You would round this to 85, and you subtract 36 from it, you get the number of neutrons. Here you round it to 40, you subtract 18 to it, you get the number of neutrons. Okay, so this is the equation that you need to use. Let's go to the next part. Now, there's another way to write atomic information, and this is the way that we write them usually when we're doing nuclear physics. So that's why this is something that we need to talk about. Okay, so here's carbon 12 again, right? So here is the mass number, right? The rounded mass number. Okay, so it's 12, and then here's your atomic number. So remember, the atomic number gives you the proton, right? So it gives you the proton and neutron and electron information. Okay, so just from looking at this, it tells you all that information. Now, of course, this C is the atomic chemical symbol, right? Chemical symbol. Okay, that's your chemical symbol. All right. Now, I want to introduce a new idea to you. It is called isotopes. They are called isotopes. So let's take a look at an example here. So on my left, and you'll see on your right as well, there's 3 examples here. So you might have heard of isotopes. So an isotope of carbon is carbon 13 and carbon 14. Now, if you look at this, you'll notice that there is one thing that is different about them. I'll give you like 2 seconds here. 1 Mississippi, 2 Mississippi. Yes, so you'll notice that the number of neutrons is what is different. So what is an isotope? So an isotope is where you have the same number, right? So I'll say same number of protons with different number of neutrons. Okay, which gives us a different atomic mass. Right? So as you can imagine, the atomic mass is going to be different. So here, right, so down here, whoops, that's very bad. So down here you can see that carbon 12 is written like that, and then carbon 13 is written like this. So remember, this 12 is the atomic mass. All right. And so here's 13 and here's 14. And sorry, it got kind of messy. Sometimes it'll be written like this as well, right? So 6, 12, 6, 13, 6, 14. Okay? So we'll call this carbon 12, carbon 13, and carbon 14. And those are the names. So that's really all the information that you need to know for this initial sort of understanding, right? So this is something that you might already know that I wanted to go over. And let's talk about our actual homework, right? So remember, the number 12 is the mass number, right? So this is the mass number, and 6 is the atomic number. So how do we calculate neutrons from just looking at this? Well, you could probably guess, right? So if A is the mass number, and Z, right? So I'm looking over here now, right? I'm looking over here. So that would mean that you can do. Right, so here's our equation for the mass number, right? Z. So n is the number of neutron plus the number of protons, plus the number of protons would give you A, which is the mass number. So in this case, you would do 6 plus something gives you, right? So it'd be 6 plus something gives you 12. Right? So that would be, right, 12 minus 6 gives you n. So as you can imagine, the equation that we want to use is going to be A minus Z gives us n, like that. Okay. So, this element is carbon, and number 6 refers to the number of protons. Okay, so remember the number of protons always stays the same as the element. The numbers 12, 13, 14 refers to the mass number, right? So that's your 12. So how many protons and neutrons are in that first isotope? That would be 6 and 6, right? Because you have 12, right? Because we just did it right here, right? So that would be 6 protons, 6 neutrons. What about this? What about the next one? Now the next one is 13, so we do 13 minus 6 gives us n. Okay, so 13 minus 6 is 7, so we got 6, 7, right? And lastly, we have 14, carbon 14. Sorry, I kind of crossed that out, right? So that would be carbon 14, which would be, again, it would be 6, and then it would be 8, right? Because you have 14 minus 6 equals n, so n equals 8. All right. Okay, so that's how you do the calculations. Folks, I think you can figure the rest of these out, but we'll do like this one together. And then there's a whole bunch of practice that I want you to do, and there will be a periodic table that will be attached in this document as well, right? Or on the homework, so you want to look at that. Okay, so let's complete this chart here. It says, how long has this video been? I don't want to take too long. Okay, so here our atomic number is 92, right? Our atomic mass is 235. So then what's the number of protons? 92. The number of electrons is 92 as well. What about the number of neutrons? Well, you want to do 235 minus 92. Let me grab a calculator real quick. 235 minus 92. That's 143. Right, so you can do the rest of these by yourself and answer these questions by yourself. Let us know if you have any questions. Have fun. Okay, bye.